Hello, everyone. Welcome back to the AAS YouTube channel. And this is part of the good stuff. This is part of the great stuff. This is the AAS Journal Author Series. And I am very happy to have Issouf Kafando with us today. Hello, Issouf.
Hello, Frank, and thanks for this opportunity.
Well, thank you so much for agreeing to
Yeah,
such a very
yeah,
lovely research note, which we'll
yeah,
get to in a second. And Issouf, where are you located at? What's your geolocation?
yeah. I live in Kingston, Ontario, Canada.
Okay,
Yeah, where I'm a professor at Royal Military College
cool.
with the Department of Physics and Space Science. So I teach physics course and laboratory in physics. So yeah,
Very nice. Very nice.
yeah, yeah.
Uh,
It's good. Mhm.
And let's see, it is February 12th of 2025 as we record this. And Issouf is, I imagine winter is still happening in Canada. Spring's not there yet.
Yeah, today, for example, we have a beautiful day, so sunny day. It's a winter time, so minus 12 today. So, but with the sun, it's a very good time, perfect time. So yeah, it's a very perfect place for me because we have no more snow, so it's a very perfect place. Yeah,
Very nice. And
yeah.
I'm in Phoenix, and we are definitely not that cold. We are sort of warming up into our spring weather today, so it should be a lovely day today. Very nice.
Oh, yeah. Okay.
You'll have to visit. We'll have to swap places sometime. You can come down to Phoenix, and I'll go up to Ontario, and we'll just live.
Yeah, yeah.
All righty, cool. Issouf, what do you like to do for research?
So my research field is on BHB star, the blue horizontal branch star. So there's our evolved star because they left the main sequence,
Hmm?
and now they after the flash helium, they burn helium in the core. So on this horizontal branch, we have uh, another group star like red star, blue star, extreme star, and variable star. So I make a spectroscopic analysis, okay, that's on the star to determine the elemental abundances and other atmospheric parameters like the rotational velocity, the abundance analysis allow to study the certification of the element and to measure the magnetic field also. So
Mhm. Cool.
yeah.
Very nice. And that is going to bring us to this very awesome research notes. It is open access. It's the open access era, people. You can go grab a copy for free. Go get one. Fundamental parameters for a sample of blue horizontal branch stars. And Issouf, take us away.
Thank you. So I will take this opportunity to say hi to Professor Carmel Robert and Carmel Robert from Université Laval in Quebec, and Francis Leblanc from Université de Moncton in Moncton, all in Canada. So the aim of this project is to identify the hot field blue horizontal branch star. So we use a spectroscopic observation of 21 candidates. So observe at Mont Observatoire du Mont Mégantic in Quebec. So with the spectroscopy, we use the models to determine the effective temperature, the gravity surface, and the radial velocity.
Cool. Very good.
So,
Very,
and the main goal for this project is to find the hot stars for other projects.
okay. Okay.
Yeah.
Good.
Yeah, so it's important to know that the BHP star are found on the hot side of the instability strip in the Esperon-Russell diagram.
Yeah.
So several study showed that the BHP star found in the globular cluster present observational anomalies, like we have the photometric anomalies, the jump photometric, the gap photometric,
Huh?
and the star found in the globular cluster present also the low rotational velocity. So,
Okay.
and the and the abundance anomalies also. So, for the field BHB star, we have not the same result because the star had not well studied. So, the star are interested because the rotational velocity fall abruptly for star hotter than this temperature. This lead to an hydrodynamically stable atmosphere where atomic diffusion may take place and lead to vertical certification of the abundances of certain elements. So such certification lead to photometric jump that are caused by the effect of atomic diffusion so on the atmosphere structure. So this project is to have the star with a temperature higher than 11,400 for this study of the certification. So we present 21 so to determine the radial velocity, effective temperature, and gravity surface by the analysis of Balmer line.
Right.
So to use, for example, the code, IRAF code to measure the radial velocity by fitting the different Balmer line and magnesium line, iron line for this exercise.
Okay.
So
Good.
uh,
Cool. Okay. Into the observations we go.
the observation were compared using the spectrograph of the Observatoire du Mont Mégantic 1.6 meter telescope between September 2013 and March 2014. And we just have a resolution around 2.3 necessary for this exercise because we need only just the Balmer line. With the slide, we have the possibility to determine the effective temperature and gravity surface. So, and cover the wavelength range from optical range also.
Okay. Good. I'm with you. Cool.
And yes, to cover this wavelength, and also we get the raw data and the data resolution and reduction and calibration. We use IRAF program to make this. So yeah,
Cool.
so IRAF program using to make the reduction of the data, raw data.
Okay.
Yeah.
I'm with you. Mm-hmm.
For the fundamental parameters, so to get the radial velocity of the star study here, we use the IRF task RV guidelines.
Okay.
So this task determines the wavelength shift of spectral lines relative to the rest wavelength from needs or valid data. And the centroid of the Balmer, helium, iron, and magnesium line were used in this exercise. So our value obtained and compared to other publication are in agreement. So, and we have just except two star where no previous value of the radial velocity was found,
Okay.
we have a good agreement within a certainty of the literature data.
Cool. Good. I'm with you.
So so it's the first time for these two star to get the radial velocity.
Huh?
is the first and for the two stars. So,
Okay.
and only HD 74721 present a larger discrepancy that is probably due to the small number of lines used.
Yeah. Okay.
Yeah, so for the effective temperature and surface gravity of each SAS study here, we use the Balmer line. You fit the Balmer line profile observed uh, with synthetic spectra created by with Phoenix stellar models. You know. At a low metallicity minus 1.5 degs.
Okay.
So we consider a range temperature, effective temperature from 7,000 to 30,000
Cool.
and the range of log G from 2.5 to 5. So, and specifically, we fit the Balmer line from H10 to H beta
Okay.
using the code of Napiworski. This code return is
Uh-huh.
chi-square value for the best fit based on the routine developed by Bergeron
Cool.
and Safer. And in comparison, we report our result in table one. So
Cool.
our result compare to those obtained by Baer and by Kinman et al.
Yeah.
So yeah, so to compare the BHP star already studied by Kinman, the value found in our study are on average lower by 124K and 0.09 for log G. So, and when we compare our result with Bear 2003B, we have a good agreement. So we also compare this result with result obtained by Brown 2003 and 2008. So, and the result is are in agreement. So for the value.
Cool. Let's take a look at table one maybe at this point. Let's see what we
Yeah.
got here. This is
So yeah, so we have here 21 target. We present the observational information, radial velocity, effective temperature, and surface gravity obtained in this study. So we have our result compared to Baer 2003 and to Kinman 2000. So, and
uh,
also other source for the radial velocity are also presented to compare with our result.
uh,
So, and are in agreement, but it's the first step of our project because we just need to confirm the temperature of the stars to select the hot BHB star for other project
right.
in situ. Yeah,
Okay. Okay. Very,
yeah. So
very nice.
yeah.
Cool.
But yeah, but in conclusion, we for this project we have just identified one hot star only BD 075093 with an effective temperature of 11,400 K in near to the limit of the odd BHB star threshold where diffusion occurs. So because we know that the cool BHB star don't know the diffusion atomic diffusion. So we need to have the hot star for this project. So, and we project to present. Okay, I just wait if you have another question for that. So,
Cool.
yeah,
Very nice. Beautiful work.
thank you.
Beautiful work. And Issouf, I want to thank you so much for walking us through your very lovely research now.
Thank you, Frank, for this time.
Sure. And you kind of mentioned it at least twice there as we went through there. So let me push on that a little bit. And where do you think we go from here, given the published article? Is there going to be a search for to get 200 blue horizontal branch stars? Is there additional atmosphere models that could be considered? And just sort of next steps. Where do you think we go from here?
So next step is to present this target at a CFHT, CFHT Canada France Hawaii telescope
Uh-huh.
for high resolution spectra to study the certification of the chemical element
Uh-huh.
and to measure the magnetic field in the star. So the
Cool.
first step was to confirm the temperature here in this paper.
Right.
So and find more target for our project. The aim is to expand our comprehension of all BHP star found in globular cluster and in the field. So
Okay.
we have more information for the BHP. It come from the globular cluster, but in the field we have the BHP star are not well studied, so we just need to present this target in, for example, in at the CFHT to get the high resolution spectra and to make a data analysis of the chemical element and to measure magnetic field.
Lovely. That'll be really cool. It'll be really fun to see this develop over the next couple of years. As we get more candidates, we get a little bit more about the chemical composition. It'll be really cool. Very nice.
Thank you. Thank you.
And that will do, everyone. And I hope this made your astronomy day just a little bit better. And we will see you on the next one. Bye bye.
Bye bye.